Good evening, everybody. This is Unit 7, Lesson 7, Factoring Completely. So far, it's time to take a look at all the techniques we know and see if we can factor polynomials that take more than one step to follow completely. We saw a few of those yesterday when we looked at the double dops examples, but let's look at the 3 steps for now that we can follow to factor a polynomial completely. The first question we always have to ask ourselves, is there a GCF? We always factor this out first. People can argue with me, they say I can do it without it. You want to deal with the smallest numbers possible, so the first thing we always do is look for a GCF. The second step we take is we look and see, is it a binomial? And if so, is it a difference of perfect squares? It's kind of nice because we can see a difference of perfect squares pretty simply. Step 3, we ask ourselves, is it a trinomial that can be factored? We will see more different types of trinomials that can be factored, but for now, we just have to ask ourselves, hey, is there an x squared? Is it a leading coefficient of 1, and can it be factored? Let's look at a few examples here. Let's take example 1. Let's take 3x squared plus 6x minus 15. Relatively simple. Well, the 3 numbers there, we really just have to look at the 3. Does the 3 go into all of these? They have no variable in common, and, well, 3 does go into all these, so the GCF is 3. The positive 3 because the leading coefficient is 3. So what I'll do is I'll take this here, I'll divide everything by 3, and I'll rewrite it in the 2 parts. You have the GCF out here, and the quotient, that becomes x squared plus 2x minus 15. Now we have to ask ourselves, okay, there's no GCF there. It's a trinomial. Can this trinomial be factored? Well, are there numbers that multiply to negative 15 and add up to 2? Well, let's see. I've got 5 and negative 3. That adds up to positive 2. Hey, guess what? It can factor 3 times x plus 5 and times x minus 3. We see those trinomials are done. They can't be factored any further. So there it is in factored form. Now notice, I keep bringing down all the factors. I didn't do anything with this 3 here. I still had to bring it down because all of these lines are always equivalent. Let's look at a second example. This example here caught my eye. 8x cubed minus 18x. I was looking for a GCF, and I said, okay, the GCF between 8 and 18. Well, let's see here. Let's look at 8 first because it's smaller. It's got a factor of 8, doesn't go into 18. 4 doesn't go into 18, but 2 does. X cubed and an x. Well, they have one factor of x in common, so my GCF is 2x. We'll take and we'll divide each term by 2x. And we'll have 2x times 4x to the second minus 9. And we ask ourselves, okay, we got out the GCF first. That's important. Second, well, it's got a difference of perfect squares, and voila, it does. 4x squared is a perfect square, and so is 9, separated by a subtraction sign. So we'll take 2x, and remember, in the first spot of the difference of perfect squares, in the first spot of each binomial, we put the square root of the first term, 2x and 2x, and in the second spot of each binomial, we put in 3 and 3, which is the square root of 9, and we have both a positive and a negative sign to finish factoring completely. We did 2 things. You can do more than 2, but that's all we have so far. Let's look at a third example. Negative 5x squared minus 10x plus 40. Now remember when we talked about having a leading coefficient that was negative. It's very difficult to factor a leading coefficient that's negative, so we're going to factor out the negative sign. We're going to include that as part of our GCF. Looking at those numbers, 5, negative 5, negative 10, and positive 40, they all have 5 as a factor, and I'm going to factor out a negative 5 since the leading coefficient is negative. So we'll factor out a negative 5. We have negative 5 times the quantity. We just have to be careful with signs. Negative divided by a negative is a positive, so x squared plus 2x minus 8. Now this is a trinomial. Can we come up with factors of negative 8 that add up to positive 2? Well, if they multiply to negative 8, they're going to have different signs. So let's see, 1 and negative 8 adds up to negative 7. Well, I want the sign to be positive, so we'll try 2 and 4. Let's make that a negative 2 since we want the sign to be positive. Negative 2, positive 4 add up to 2. There's our choice. Negative 5 times x minus 2 times x plus 4. We have factored completely. These examples can all vary in level of difficulty. We've gone 6 minutes. I think I'd like to have you try a couple. Let's have you give these two a shot. There's 2 steps in each of them. I gotta fix my little typo there. There we are. Give those a shot and pause your video. We'll wait for an answer. So, and the answers will appear in 3, 2, 1. Well, ta-da! There are the answers. Hopefully it's going well for you and it doesn't seem too difficult. We'll get more practice with different types of problems. Believe it or not, there's still quite a few different ways to factor here. I'm going to put a couple up here that I want you to see, maybe with more variables here. Let's see if we can get... I'm going to throw this one at you because I've seen it in multiple choice more than I've seen it in actual factoring. It's tricky because there's 2 variables. You got an x squared and a y squared, and then the middle term has the variable, the xy. Well, the first rule of factoring, as I said, is always the GCF. So that's not the problem here. They all have a number in common, which is 2. They have no variables in common because 2 of them have x's, 2 of them have y's, but none of the 3 have anything in common that is in common to all 3 besides the 2. So we'll read this as 2x squared plus 1xy. Remember there's a 1 there, minus 56y squared. Now, I'm going to bring down the 2 first, and this is a trinomial. It's going to factor. We should probably realize that the first term, think for what the product of the first 2 terms has to be. That's right. It has to be x squared. So I'm going to put an x and an x here. Now the middle terms, they have to have a coefficient of 1. The middle term has to have a coefficient of 1. Well, if we thought of numbers that multiplied to negative 56 and added up to positive 1, we'd have a bunch of choices. We'd work through our list and get 8 and negative 7. They add up to 1. Now the issue we have here is the y squared. Well, if I put a y in both of the second spots, y times y is y squared, and y times x is xy. So really, I've got the x's in the first spot of each binomial, the y's in the second spot of each binomial, and lastly, just got to look at, hey, I've got these numbers right here, plus 8y minus 7y. if I went through and I used a double distributive property, I would see here that I get x squared minus 7xy plus 8xy minus 56 y to the second. Well, and then again, it's times 2. So we'd end up getting what we started with. So I just did my little check here, and it worked. That works well sometimes if you have an x, y term in the middle. It's the same as, it's got one part of each of those. All right, that's enough for today. Have a good night.